Hello and welcome to my video on my tool post mill for my lathe. You can see the main parts of the side mill, and I'll put a CAD model up later of explaining and detailing more of the parts. You can see a small DC motor here, 120 watts, some rocker arms cast up aluminium. That's really to tension the belt. So the main body, one of the earlier versions I made, put it in the 4-jaw chuck, machined some surfaces there for the rocker arms, the slot for the tab for the main hub to fit on, the two acetal pulleys here. You can see I have an ER 11 collet chuck there. I can actually remove the ER 11 collet chuck simply by releasing the cap head screw at the back, holding it with the spanner, and it will knock out, and I can replace it with an ER20. I call it Morse Taper 1 chuck, and I'll show you that in the CAD model, because I thought it would just be useful to give you a demonstration of the mill in action. So if I just start it up, so you can see it's running, and if I move it in, that should be enough for the purpose of the demonstration of the video. You can turn it off. You can see that there's quite a clean cut there. If I remove it from you can see a couple of examples there that I've made before, but you can see here. It's better, so you can see it's quite clean. There's not much chatter, so I'll go into more details of how I made it in the next video I'll put up. I'll just show you a short clip of the run out on the tool bit, on the end of the chuck's about 50 microns. So see you in the next video. Hello and welcome to my video on how I built a tool post mill for my lathe. So the motivation for this build project was that I was using a Dremel style tool on the tool post initially for sharpening tools, putting pilot holes in parts, but it's quite limited simply because it lacked power and I could only hold drills of up to 2mm shank diameter, small grinding wheels. It was quite limited. It burnt out. I had to look online at something more capable. It was quite expensive, so I decided it's time to build something for myself. I seen people had used drills, angle grinders, made brackets, melted them in the tool post. My lathe was quite small, and I wanted something that I could also control the speed on, which I felt was important. I've seen custom solutions involved using cable drives, and then I've seen others where it was a more compact tool like the one I'm showing you, but there wasn't a lot of detail online, so I thought I'd make a simple CAD model to show you what I had done and give you an idea of the limitations. So the main body of the tool was machined out of mild steel. fits in the tool post. I've got my fine adjusters. I've got my rocker arms. I cast those out of aluminium. You could easily make them out of steel. I was just trying to get the weight down so there wasn't so much weight suspended on the tool post. Because I don't want vibrations obviously and chatter. I used a 12 volt DC motor, a reasonably cheap one. I have a controller already that I use for my power hacksaw and my mill, so I can use the same controller in this. Just use banana plugs and off we go. The pulleys were machined out of acetal, so it's quite easy to make those parts. A simple standard V-belt. Move the rocker arms back to tension the belt. The size of the pulleys, really, I just done those by eye. The maximum practical size and dimensions of that I can make them to make a belt fit, and it seems that I can machine steel with no problems using this setup. So I've got enough control on the speed for a bit of grinding and for, as I say, machining steel. The main body here, which the spindle sets, was the hardest part to make. Initially, I had this tab here that locked with these two screws, was welded on, but eventually ended up silver brazing it, and I'll show you why. Just look at the cross section. So the main hub body was made out of tube, machine surfaces, the bearings located onto the inside surfaces of the tube, and this red part, this main shank, there was an interference fit again with the shank to the bearings, and an ER11 collet with a Morse taper 1 fit with a cap head screw just to lock it in position. I like this design because I could change over to like an ER20 collet, so if I needed to hold 8mm diameter end mill, obviously the ER11 collets, I think they only go to maybe 6mm or 7mm, so I could hold something bigger if I needed to. This spindle, I could essentially machine it, most of it, in one passing. I could machine the interference fit, I could put a thread on the part that allowed the lock nut and the pulley to tighten together. I could put the hole through, and then for the taper fit, I would turn the spindle around, clock it in the 4-jaw chuck, and just use a plug reamer. So a limited number of operations, and it's also quite versatile. Initially, I had bought an ER11 collet and clocked it in, but the surface here, just the supporting with the tailstock, I never really quite got the accuracy. And combined with that, and initially I had a tab with a welded, hub with a welded tab on it, and while it was strong, it was like clocking in a banana. I could never really get it clocked in very well using the 4-jaw chuck. I tried twice and I always had runouts of 0.1mm or more. With this design, I ended up with the main body just machining in a keyway, cutting a bit of flat bar, just pushing it in and then just silver brazing it. And I'd done that even after the machining, which wasn't even the ideal way to go about it. Initially I'd done it just to see would it work, would it be strong enough, and I'd machined the surfaces for the bearings after, and the run out was about 50 microns, so I've just left it, but I'll probably get round to doing it the correct way round again. So I think that was the main parts of the build. The reason for the thread on the pulley and the lock nut rather than a keyway or a pin was because I could fine adjust the preload on the bearings, and I didn't have additional setup. I put a little flat on the spindle, which allow me just to hold the spindle as I turn the pulley on. Yep. The arms I used, I sandcast those, but there's probably out of aluminium, but there's probably other ways you can make some sort of rocker arm or fabricate it. So in the next video, after the CAD model, you'll see a video of the run out coming up at 50 microns. Then I've got a short video just showing you it locked in the tool post and just doing a side cut. But if you've got any questions, please get in touch, and if you like the video and you find it useful, please like and subscribe. Thank you.